Hey guys, what's going on? My name is Sergey, and today I'm going to talk to you about sorting algorithms, and in particular, I'm going to talk to you about selection sort algorithm. And this is a very pretty simple and straightforward algorithm to implement, but it doesn't mean that it is less powerful than other algorithms. It doesn't mean at all, and the reason I decided to film this video is because, to be honest, I have not found too many videos related to this kind of topic. Maybe I'm wrong, correct me if I'm wrong, of course, but seems like that there are too many videos which are focused on JavaScript, frameworks such as React, Vue, Angular, things like that, modern technologies. But people, at least in my humble opinion, people tend to forget that, programming, generally speaking, is considered to be, working with and understanding, of course, working and understanding algorithms. All right, and without these fundamental things, I believe that one can't consider himself or herself to be a decent, programmer, developer, etc., etc. Maybe I am wrong, of course, but I think that practicing and knowing at least some popular and useful data structures and algorithms is not gonna hurt. I think that these kind of skills they will bring about positive changes into your health. I mean into your mind, I would say, because so how should I put it in the right way? I think that one should practice algorithms not only because you might be preparing for an upcoming coding interview, but for your mental health as well. Is It's really beneficial, I believe. It's just like going to the gym when you lift weights, and the same can be said about working with algorithm and solving little issues, because they might help you become a decent programmer. But enough babbling, and today I'm gonna use the C++ programming language. I tend to use this language because I've been working as a system programmer for several years, and because of my background in mathematics, these system programming languages such as C and C++, they kind of near and dear to my heart, so to speak, if I can say so. But it doesn't mean that I tend to neglect other modern programming languages such as JavaScript, Python, and Java maybe. So, but anyways, I'm gonna start with absolute scratch, and I'm using. I'm by the way, I'm on the Linux Ubuntu operating system. You might use whichever operating system you prefer. Really doesn't matter. It's just my preference, and yeah, I'm pretty comfortable with this operating system. Yeah, let's get started. So, as already mentioned, I'm gonna start with absolute scratch, and yeah, I'm gonna use Visual Studio Code, and you, of course, you can use whichever editor you prefer using. Really, it's up to you guys. Alright guys, and to get started with, I'm gonna spend a couple of minutes explaining to you guys what selection sort algorithm means. Basically, as already pointed out before, it's pretty straightforward algorithm, just like bubble sort algorithm, with the exception that if we consider an array, for example, of n elements of integers for the sake of simplicity, I suppose we set the first element of the array as the minimum element, and then step by step we're gonna compare the minimum element to the second element adjacent to this element, right? And if this second element is gonna be less than this minimum element, that means that the minimum element is gonna be 12 now, and the process goes on until the last element. All right, and if, for example, for instance, if our third element of the array is not gonna be greater than this one, we just do nothing. We skip this element and we go to the next one. So the process goes on, as I already mentioned before, goes on until the last element of the array. And when we reached the last element of the array, which is the minimum element, as we already figured out, right? We should place this last element at the beginning of our array. All right. So and the process goes on, starting with the second element, then the third element. This algorithm can be and should be implemented just like that. All right. So without further ado, let's get started. As I already mentioned, I'm gonna use C++, and I'm gonna start with a blank file. And guys, I'm gonna comment my code as much as possible so that you guys will be able to refer to it later if you wish, of course, to do so. Alright, so I'm gonna say implementation of the selection sort algorithm in C++. Alright, so let's define our strategy. Alright, alright guys, the first step, as already pointed out, we need to define to set the first element of the array as the minimum element. Alright, the second step, we should compare the minimum element with the next adjacent element. If the next element is less than the minimum, the next becomes the new mean element, I believe. Alright, so, and we should say this process, and we shouldn't forget about the fact that if the next element is not less than the minimum element, we do nothing, right? Just go to the next element of the array. Alright, so the third step would be when we've reached the end of the array, put the minimum element at the beginning of the array, right? And after each iteration, I believe, we should start comparing our elements with the next unsorted element. So we should start with the second element, right? And the process goes on until the end, after all the, and probably I should comment it as well. This process goes on until all the elements are placed, right? Placed in the correct order, I believe. That's our strategy, alright? So first of all, we should in the C++ programming language, we should include a couple of vectors. In fact, we should include only one IOStream, alright, in order to work with input and output. Okay, and we need to prototype some functions. Function prototyping or forward declaration, I believe we can say. Declaration, alright. So first, we need to declare the swap function. Alright, we're gonna say void because it's not gonna return anything. We're gonna say void swap, and this function is gonna take a couple of parameters which are gonna be type of pointer. Since we use C++ and we're gonna work with memory addresses, we should use pointers in order to perform swapping operations. Alright, so here we need to introduce temp variable in order to swap to adjacent elements, I believe we can say. So we're gonna say int, and by the way guys, all of our elements are gonna be type of int, just for the sake of this example, this small example, right? And for the sake of simplicity as well, so that we won't overcomplicate things. We won't make things a little bit complicated than they really are. All right, so we're gonna say in temp is gonna be equal to pointer of a, and next we're gonna say a pointer is gonna be equal to b pointer, and finally we're gonna say b pointer is gonna be equal to the temp. Okay, yeah, basically that's it. And so just to reiterate, to make things a little bit more clear, I'm gonna say that we're using pointers over here because we won't be working with copies of variables, which might be, first of all, they might be expensive, of course. For this little example, that's not the case, of course. But if you are working, for example, with objects or arrays, even, it's not a good idea to use copies, and instead we should directly access memory location of this or that particular variable in order to make our algorithms more efficient, and to add some speed to our algorithms. All right, so, and by the way, I like to separate my declaration from definition, and that's why I think we need so let's first of all scaffold out our main function 0, and here we're gonna say function definition. Here we're gonna define our functions. All right, so I'm gonna copy just this function. All right, just place it down here. Here we just don't need to define the body of the function, we just need to prototype it up here, and that's it. Second function we need to, and the second function we need to, you know, we need to perform the selection algorithm, right? We're gonna say selection sort function, right? It's gonna be the type of void as well, because it doesn't return anything. Selection sort, we're gonna call it. So, and as I already showed you guys on that picture, we're gonna use arrays. We're gonna work with arrays. So with the type of int, we're gonna say array, pass an array here, and we're gonna need to declare the size of the array, because you know, in case you're not familiar with C++, guys, for those of you who don't know it, so I am gonna say that I'm gonna explain it a little bit in a couple of words. So if we don't pass you know, the size of the array into a function, that means that our array is gonna decay to a pointer, right? It's you know, this issue is known as you know, pointer decay. It's not an issue, of course, but in C and C++ programming languages, arrays behave just like that. You know, that's why we need to C style arrays. They don't know beforehand their size. That's why they are not too flexible, right? And that's why we need to, you know, explicitly pass the size of the array. All right. Yeah. And if you are confused about this, you know, syntax, I think that you might go on the internet and figure it out for yourself. It's not too difficult, but it's not you know, the topic of our discussion. All right. So anyways, guys, we're gonna use two for loops. One for loop is gonna be an external for loop, where we need to iterate through all the elements of the array. All right. So we're gonna say for int step. So we're gonna call this variable step. We're gonna start with 0, step 0, as long as the step is less than the size of the array minus 1, you know, because we don't need to compare the last element. So let me bring you this little picture so that you might be able to understand it a little bit better. When we reach the end of the array, right, we don't need to compare this element with the next element, all right, because we don't need anything to compare it with. Yeah, that's why we need to subtract the size of the array by 1. Okay, hopefully that makes sense, guys. And really, it's not too hard to figure it out on your own, to be honest. Okay. But anyway, guys, yeah, and I forgot to increment our size by 1, size plus plus. So here we need to define, I would say, define min index variable, so that we can start from the beginning of our array, and we can compare the first element with the second one, and so on. All right. So we need to say min index is going to be equal to the step to get started with. So it's going to be equal to 0 because we're starting here, from the head, from the beginning of the array. All right. And here we're going to use an internal for loop, because for each element we're going to compare for each iteration, I would say, right? We're going to compare to adjacent elements. All right. So we're going to say for int I, we're going to call it I is equal to step plus 1, I would say. So because we're comparing the first element and the second one, that's why it's gonna be step plus 1, as long as yeah guys, as long as I is less than the size of the array. All right. We'll go until the end of the array. Okay. And we need to just increment I, okay, by 1. So here we need to compare the two adjacent elements, and if the second, right, starting from the beginning, I would say, starting from the beginning of the array. All right. So if the second, the next element, I would say the next element is less than the previous one, it is gonna be, then the next is new minimum, right? So we're gonna say if if array yeah guys, we're gonna say if array I is less than array min index. So let me bring you a picture one more time. So we're comparing two elements. If this element is less than this element, that means that this element 12 is the new minimum element. All right. So and we're gonna say that what are we gonna say? Yeah, we're gonna say min index is gonna be equal to y. So basically we're changing the index of our element to this, right, to this element. Yeah, and yeah, basically that's it. So, and after each iteration, after we are done, after we reached at the end of the array on the first iteration, we're gonna need to place to swap two elements. All right. We're gonna put, so I'm gonna say so we now at the step number 3. All right, we'll reach the end of the array and we need to put the minimum element. So I'm gonna say put the min element at the beginning of the array. All right. So and we're gonna say, yeah, we're gonna we're gonna invoke this function, hey guys, and I think we should probably copy this function down here so that our code is going to be a little bit more readable. Okay, so right, yep, like this. So here we need to just prototype our function, I believe. Okay, like that. Yep. So guys, just 1 second. Yeah, we need one more color brace down here. Yeah, I think that should do it. Alright, and here we're gonna need to invoke our swap function. Alright, so we're gonna say swap invoke the swap function. Alright, we're gonna say swap, and we're gonna need to pass our array the address of this address. We're gonna need to pass an address of this variable of the array, since we're using pointers, right, as we were talking about before. Right guys, alright guys, we need to swap for example, so let me bring this picture one more time so that you guys will understand it a little bit better. So when we reach the end of the array on the first iteration, right, we need to place this element at the beginning of the array, so we need to swap these two elements. Okay, so we're gonna say array index, and the second argument is gonna be array step, I believe, because it's the first element, right, this element. Alright, we swapping these two elements. Okay, yeah, and I think that should do it, guys. And the last function which we're gonna implement in this little algorithm, I think that we need to print elements of the array. Print elements function. I'm just gonna call it. I'm gonna comment. We're gonna say print array. Let's see. So, and we're gonna need to pass an array and its size. Okay. Alright, and down here we're gonna need to implement this function. So I'm gonna say print array. Alright, no, array and int array, of course, because we agreed, I remember we agreed to use the integer type of our variables, okay, for the sake of simplicity. Alright, so we're gonna say iterate through each element of the array and print its values, right, on array on each iteration. Alright, so we're gonna say so first of all we're gonna need to let the user know what the heck is going on, and that's why we should say std_cout Next we're gonna use for loop int I from 0 as long as I is less than the size of the array I plus plus. Okay, here we just say stdc out, and we just displaying all the elements of our array. So I, we're gonna put space here, and after we're done, I think that we should print a new line. Right, cout, new line. All right. Yeah, guys, I think that should do it, and now we're ready to, you know, to test our little algorithm. So first of all, we're gonna need to define a new array. So we're gonna say, you know, int array1 is gonna be equal to, let's say, array of integers 50, 25, 3, 5, 100, you know, 9, 0, and 7, for instance. Alright, and that should be enough, I believe. So now so first of all, we're gonna print, I believe. So we're gonna say std out, the original array. Okay. So and we're gonna implement the for loop. Just to show the user the original array, so that they will be able to compare it with the sorted array. Alright, after we're done, I equal to 0. Yeah, and we need to figure out the size of the array as well, guys. Yeah, I forgot about it almost. Sorry about that, guys. To calculate the size of the array in C and C++, we need to divide, to use first of all size of function, the size of the array in bytes, right, by the size of the first element of our array, or really it could be any element, but for the sake of simplicity we're gonna use the first element. This way we'll figure out the size of the array. Alright, the number of elements of our array. So we're gonna say for int I, as long as I is less than size, right, I plus plus, and we're gonna say std out, array 1 I. Yeah, we're gonna need to put space up here. Next we're gonna need to alright, then we should invoke our little function, select sort function, selection, sort function, right? Alright, guys, we're gonna say selection, sort, and we're gonna need to pass our array 1, okay, and we're gonna need to pass the size of the So after that we're gonna print our array, sorted array onto the screen to the user. So we're gonna say one size, and yep, as I've talked about before, we don't need to pass the address of the array in order to work with pointers, because by default you know, arrays are gonna decay to pointers. They're gonna pass by reference, you know, unlike other data types such as primitive data types such as integers, you know, floats, you know, things like that, right? Strings maybe. Okay, and now I think that we should be able to test it out. We're gonna compile our program. We're gonna say C++, G++, sorry guys, selection. Yeah, we're gonna need to move through. So we're gonna need to move to selection, and we're gonna compile our program. Selection CPP. Okay, seems like we don't have any issues, which is a good sign, by the way. So, and now we're gonna run our program. So, alright guys, seems like we have a little issue, and I think that it's here. We should have incremented step by one, not the size, of course. Stupid me, sorry about that guys. So let's recompile our program one more time. So let's run it. So yep, seems like our little algorithm is working correctly. Everything is sorted in an ascending order. And by the way, if you wanna sort your array in the opposite order, in the descending order, you just need to you know, replace this less than sign with the greater than sign, and that's it basically. And in order to prove you that I'm not lying to you, we just, you know, just do like that, just compile it and run it, and yep, now our little array has been, you know, sorted in the descending order. Okay, so yeah, alright guys, you know, as you can see, it's pretty simple, pretty straightforward, right? But I think that those little, you know, algorithms and practice, it really doesn't hurt. Practice never hurts, you know. The more you practice, the better you become at what you are doing, I believe, and that could be applied pretty much to anything, not only to programming, but I think that it is true for every, you know, expertise, for every, you know, part of your life. And to be honest, and I think that I must confess, guys, that as you've probably figured out before, I'm not a native English speaker, but with a little effort I'm gonna try to do my best, and I am trying to do my best, you know, to explain to you concepts, different concepts of programming, even in a foreign language for me, you know. And if somebody is curious about it, my native language is Russian, and which you can see in my accent probably, but it doesn't matter. And I think that with little practice, I'm hopefully I'm, you know, I'm getting better and better in my spoken English. I don't have any issues with written English because, you know, I, you know, try to read at least every single day, but doesn't matter. Of course, it's not about myself, it's about programming and algorithms. Yeah guys, and I think that if you commit yourself to practice, even, you know, just 1 hour, one and a half, you know, hour of practice, every single day, or even in a couple of once in a couple of days, it would be a good idea to get started with. I think that not only by doing so, not only will you be able to become a better programmer, better problem solver, alright, but also it's gonna benefit you greatly. It's gonna be very helpful and useful for your mental health. Okay, so enough babbling, guys. I think that we can stop here. I believe that, strongly believe that these videos might be useful for anybody really who is getting started, who are getting started with programming. And yeah, guys, hope you're doing well. And yeah, I really sincerely appreciate everybody, every one of you who spends their time watching my little videos, little series, or whatever you can call it. Okay, so guys, all right, all the best to all of you. Take care, and I'll see you next time. Bye bye.